Hello guys, my name is Ali. You are welcome to part 2 of this class. And we want to talk about 11 questions. What we have here on the board is 7. Now we're going to be fast with it. Now the question says, if a bar is accidentally broken into 3 places, as shown above in the polarity of P and what? Okay, as shown above. Sorry. Full stop or comma. The polarity of P and Q respectively are, that means if you take a bar magnet and cut it into 3, the polarity of this P and Q here. Now don't forget that as you break the magnet into 2, they retain their polarity, which is north and south. So this one will be north, south. It will be what? North, south. Then you have the north, south. That's how it's going to be arranged. So that I can end the south, they give it to us. And you cannot have north, it's not possible. So that is not the P will be north, while Q will be south. Now, this particular number 2 is actually talking about a diagram of 2 poles that are repelling each other. And the only reason why 2 poles can repel is when they have the same polarity. Now, when they have opposite polarity, they will attract. You understand? So this one is repulsion. But this arrow I'm trying to look at is, or that I'm looking at rather, is going inward. So whenever the arrow is going inward, what does that mean? To signify? It signifies that this one is south, this one is south. If the arrow is going outward now, it will be north. So since it's outward, is inward, the arrow is going inward, there will be south, there will be south. So I will go with B, option B. Now don't forget, when it is outward, it is north. But when it's traveling from a 2 unlike pole, it will go from north to south. Please don't forget, the direction of the field will travel from the north to the south. That means if you have 2 polarity, for example, let's say I have a polarity of this kind. Let's say I have north and south, for instance. So if I have north and south now, for instance, it will travel to the north, to the south. That means it will take from north to south because they are unlike poles. Now let's continue. The next question says, a north pole of a magnet can never be separated from the south pole. Because I've talked about this one, because a magnet exists as a dipole. Check the first part 1 question that we have solved. Number 4, it says, which of the following material would be most suitable for construction of core of electromagnet? The core of electromagnet is what the material used for what? To construct electromagnet, not the wire. The coil is the wire. If I say the coil, I will have go for copper. But since the house of electromagnet require a temporary magnet, not a permanent magnet. So I will go for what? For iron. Don't forget, to construct electromagnet, the better material to use is what? Because we need the material to be easily magnetized and easily magnetized. An example of what an electromagnet instrument or that require this electromagnet is electric bell. Let's continue. Number 5. In order to prevent bar magnets from losing their magnetic strength, they are stored in keepers. They saw that the 2 bar magnets are placed with, now this is how the keepers work. The keepers will work like this. Look at the board, class. If I have a magnet here, I have another magnet here. Now these 2 magnets, one is north, one is south. Here will be south, here will be north. So that when we use it, we'll put the keepers at the end to key it together, to close it. Here will not be north, here will not be south. Put another one here. So here will not be what? So north, here will not be south. So that we can key it, so that you not allow the earth magnetic field to penetrate the magnet, because the strength of the magnet is located at the end. You cannot put, so there are 2 parallel or like poles placed face to face with each other, and what? The ends are what? Are placed with what? Are covered keepers, are closed with keepers. So that they will not be exposed to the what? To the what? To the environment or to the earth. So light poles facing each other and the keepers placed at the end or at their ends, no. Light poles facing, no, that one is already on. Light poles facing each other with the keepers placed at their end, yes. I think this one is correct. On light poles facing each other, and the keepers placed between them, no. So number 7 now, before we go to the next, number 8, where we now this one said what? In electrical method of magnetization, the polarity of the magnet depends on dash. Now the polarity of a magnet depends on the direction of the current. The direction of the current, not amount of current that passes through, not the magnetic material, no, not the size of magnet. It depends on the what? The direction of the current. Don't forget, in a solenoid method, for instance, that is the electrical method, current enters through this what? Through the south or through the south, yes, and come out through the north. So if you want to have something like this, I want to have something like, look at the board. This is a solenoid, for instance. Maybe you have a solenoid like this, okay. Then we have what? The cell. Then we have what we call the bar. The bar or the steel magnet, which what it pass through. And you must make sure you withdraw the steel magnet in the north what? South direction. So that at the end of the day, you will notice that the clockwise movement is the south, while the anti-clockwise is the what? The north. So it's clockwise. So the current will enter here and the current will leave through here. So this is how it works. So in that is current, where the current enters through is the south, where the what current leaves is what? The north. But don't forget, it's opposite to the direction of field. Direction of field, the magnet what comes from the south and enters. That means it's what? More or less like a magnet, yes. I think it's the same thing as magnet. Works, the solenoid works almost similar to magnet also. Yes. Now let's go. Let's go. Now, the next question says, let's look at number 8. Number 8 says, which of these is the best method for demagnetizing a steel magnet? Don't forget that the solenoid method is the best method of magnetizing a magnet and also demagnetizing a magnet. But the best method of completely demagnetizing a magnet is heating method. Don't forget. Now, this answer is what? A. Don't forget, there are methods of what? Magnetizing of demagnetizing. You can use it by heating method. You can use by hammering. You can use by rough handling. Hammering in the north, east-west direction. You can heat, and heating, one of the disadvantages of heating now is that it completely what? Destroy the magnet because when you heat, it completely demagnetize the magnet. And what happens when a magnet is completely demagnetized? It has affected the magnet itself, which is the material, the steel material of the steel bar magnet itself. So that's why this method of demagnetization is not advisable, because the material in quote, the steel bar magnet, might not be useful again for magnetization. So the best method to magnetize is this one. Now, rough handling is also the magnetization. The best method of magnetization B. The rough handling is magnetization, and hammering also the magnetization, but this is the best method. Now, if they ask you the question, which of these following is the method used to demagnetize a steel bar completely? That be heating. The second of that, very common question. So which of the following elements are real magnetic material? I gave you a shortcut that way, which is coins. Coins is a shortcut to remember. What does it mean? Cobalt, iron, nickel, and steel. So let's go. Steel, iron, and nickel. Yes, that one is correct. Copper, steel, no. Lead, no. Brass, that one doesn't. Glass, no. Option A will be better. Steel is more suitable than iron. I told you steel is for permanent magnet, iron is for what? Temporary magnet. So for me to employ steel, it means that for me to use steel, It means that I must agree that the what I want to use it for must be what able to retain magnetism for a long time, because this thing retain magnetism for a long time. This steel also what not easily magnetized and not easily demagnetized. So that is the advantage it has depending on the usage. Now the question says what is suitable for iron because the former, what are they talking about? That means steel. The latter is what? The latter is what? Iron. While the former is steel. The former is easily demagnetized by shaking. No, vigorously. It's an alloy of many metals. No, it is easily magnetized by AC. No, we only magnetize by DC. Please, so when we're talking about this demagnetization, to magnetize, you connect your solenoid to an AC, to a DC. But in the magnetization, if you check the diagram I drew last, I use the cell of this kind. This cell is DC. Check my last question. I think the last question I did, question 7. Now, look at this. The question says, it said what? Which of the following method? Okay, I think we are in option C. It says it's an alloy of many metals. B, it's easily magnetized by no. It's easily demagnetized by AC. Retain its magnetism more than iron. This is the context of the answer that suits the question. So this one is even the correct answer here. G. It is what? Still retain magnetism more than iron. Number 11, which is last question. It says which of the following method cannot be used to produce a steel magnet? Passing a what? Electric current through solenoid, yes. Repeated stroking of the specimen, yes. Single stroke. Repeated stroking of the specimen in opposite direction, double stroke, yes. Eating of the specimen, oh, that one is out of it first. I don't want to know what the last answer will be, but from that, eating is a very wrong method of magnetizing. Hammering the specimen in the eighth magnetic field is also correct. Don't forget, when you hammer in the north-south direction, then you achieve what they call magnetization. Don't forget, there are four major ways of magnetizing a magnet: by electrical method, which is the passing a solenoid or connecting a solenoid to a DC. 2, you will use a single stroke method. Single stroke method is that method that you use. In other words, that means when you are using single stroke method, you what? Look at something like this. When you are stroking, you continue stroking with single stroke. This is the material we want to what? Magnetize. When you stroke with south, this end will carry what? North. But when you stroke with this is the magnet. Now, when you continue to stroke with north, you here will be south. So stroking with a pole will give you an opposite pole at the end where the stroking ends. Then double stroke, although this one does not give equal strength, but here will be south, does not give equal strength. If here is not, here will be south. But if you use double stroke, it will give you equal strength, meaning that you stroke with north here and stroke with south, ensure it's at the middle. When you stroke here like this, and you stroke this one like this, now what will happen is that what will happen is that when you are stroking, this end will not be south because you are stroking with north. Here will not be opposite pole south. But when you are stroking with south, here will be opposite pole north. What if I change this into north and south? That means this one will not be what? South, while here will not be north. That is double stroke for you. So I've explained double stroke and single stroke for you. Don't forget to what? To liking and share this video. Please, I'm able to explain all those things for us, so we now understand what a double stroke can do and what a single stroke can do. So when you repeat your stroke with a specimen, stroking of a specimen, I'm using a bar magnet, you have that. Now, please ensure you subscribe. My name is Engineer Holiday. God bless you. Watch more of our videos and ensure you share this video with other persons. Thank you.